Okay. Number 9 says fill out the table below by circling one choice in each box. So if I have an endothermic reaction, it's going to feel cold because energy is being taken in. The energy of the reaction is going to be positive. Energy is being absorbed. If I have an exothermic reaction, it's going to feel warm or hot to the touch. It's going to be negative because I'm losing energy, and energy is released. Please know these things. Please, please, please. All right. Let's look at number 10. Number 10 says, use the potential energy diagrams to fill out the table below. So I said, okay, and I'm going to just read off the chart. Energy of the reactants is, well, here's my reactants, 20 kilojoules. Here's my product. Energy of the product is 50 kilojoules. Energy of the activated complex, well, here is my 70 kilojoules there. I have 20 there. We just said that the energy of the activated complex was 70 kilojoules. Just read it right off of there. Delta H is H of the product minus H of the reactant. So products were 50, reactants were 20. Looks like a positive 30 kilojoules to me. Okay. And then my activation energy would be the 70 kilojoules for the high point, the activated complex, minus the 20 kilojoules of the reactant that I started with. And if I did that correctly, I got 50 kilojoules. And that's a 3 right there in case you can't, man, that's a mess. Hang on, let's fix that. Positive 30 kilojoules. All right. Endothermic or exothermic, well, I look at delta H, it's positive, and we said up there that a positive delta H was endothermic. Because the system is gaining 30 kilojoules of energy, and if it's gaining, it must be absorbing it. Okay, look at this one here. Energy of the reactants is 100. Energy of the product is 50. Energy of the activated complex, that's the top of the hill, looks like 175 to me. Delta H is heat of the product, our energy of the product minus energy of the reactant. So that's 50 minus 100. So I'm getting negative 50 kilojoules. Activation energy, well, we said that was the hilltop, 175, minus the reactant. So I got 75 kilojoules. This right here is negative, so that tells me it's exothermic. Delta H is negative, so it's exothermic. Heat is given off, so heat is released. All right. So we're going to move on. All right. So anytime you see these diagrams, go ahead and make that label there so you don't forget. That's my catalyst. The dashed line and the smaller is always a lower hill. That's the whole point of a catalyst. So that's my catalyst. All right. It says, so the solid line represents the uncatalyzed, and the dashed line represents the catalyzed, lower hill, less energy needed. That's the whole point of a catalyst. What is delta H for the catalyzed reaction? So catalyzed is here. So I'm going to have 65 for my reactants and 50 for my products. So I'm going to say products minus reactants. So I'm going to say 50 minus 65 equals negative 15 kilojoules. What is delta H for the uncatalyzed? Same thing, nothing changes. 50 minus 65 equals negative 15 kilojoules. What is the activation energy for the catalyzed reaction? So it's 75 at the highest point It's 65 at the lowest point. It looks like to me it's 10 kilojoules, but I'm might be messing up, so let me see. What is the activation energy for the catalyzed reaction? Hang on. All right, so I was right. It's the top of the hill minus the reactant. So the top of the hill for the catalyzed looks like 75 minus 65 or 10. And then for the uncatalyzed, it looks like it's 90 minus 65, which is 25. Now, if I have this wrong, you'll have to forgive me, but I think I'm good to go. Good luck on the test. Adios.